Okay, so we are looking at these different performance parameters, and we have reached to a stage where we are looking at range and how the range is kind of affected due to the overall efficiency and exit velocity. Now, the other parameters which could be important to look at is the endurance and how the aircraft actually get affected due to other forces while climbing or decreasing descending, because when we have looked at the range, that time one of the biggest assumption that we have made that there is no climb up or there is no descent from the level flight. So, assuming the level flight, we have looked at that, but let us continue the discussion from there. And then, so again we say that what we have looked at is the range assuming level flight. So, that is, which means the level flight talks about that if this is your aircraft, then thrust is balanced, this is weight and this is lift. So, this is what you call by the level flight, where all this thrust, lift, drag, they would be. Now, we have already looked at L by D ratio and all these. Now, this could be also can be represented in the range formula, where we have used as L by D, we can also replace that CL by CD and something like that. Now, CL is essentially the lift coefficient and CD is the drag coefficient. Now, this we can represent like we can write CL is, let us say, W by half rho U square SW, where U is the upstream velocity or free stream velocity, whatever you call it, the upcoming free stream velocity, W is the weight, what we mentioned here, weight of aircraft, SW is the wing area. Okay. And the drag coefficient can be calculated like CD is K1 CL square plus K2 CL plus CD naught, where constant K1, K2 and CD naughts are the typically they are the function of flight Mach number and wing configuration. So, when you talk about wing configuration, that means this includes the flap position like that. Now, CD naught is the 0 lift drag coefficient. Okay. So, this accounts for both frictional and pressure drag in the subsonic flight. and so this accounts for both frictional and pressure drag in suspended flight, and for supersonic flight it is the wave drag. And the term K1 and K2, they account for the drag due to lift. Normally K2 is small and almost equals to 0 in most of the fighter aircrafts. Okay. Now, already we have seen, just to maximize the range, what we need to do, we have to fly at the maximum lift to drag ratio. Second, have highest possible overall efficiency. 3, have lowest specific fuel consumption, that means TSFC or SFC. 4, have highest possible ratio between the aircraft weights at the start and end of cruise. These are the things that we have already seen. Now, for a turboprop engine, let us say for propeller or reciprocating or turboprop engines, similar analysis can be followed. Okay. Now, what we can write there is that U T by m dot f would be eta PR by effective specific fuel consumption. So, this will get us the range for eta PR by G 1 by ESFC L by D ln m1 by m2. Obviously, again if you look at this expression, to maximize the range, this lift to drag ratio to maximize S L by D propeller efficiency. So, these are also to be maximized. Okay. So, these are now, so typically the airlines, they normally follow the following Breguet relation. Let us say for turbojet or turbofan, they say S is U by C L by D L m1 by m2, where and for turboprop they usually say eta by C L by D ln m1 by m2. Here C is specific fuel consumption, and similarly one can define the also write the specific range, or another definition is also employed, that is specific range. So, that also can be used. So, that is like which given like either miles per pound fuel or kilometer per kg of fuel consumption, something like that. So, for example, turbojet and turbofan, this mi by per pound of mass flow rate would be U by C D by L into W, which is U by C L by D into 1 by W, where U is in knots and mi per LB will be in nautical miles per pound of fuel, nautical miles per pound of fuel. And in a similar fashion for turboprop, you can write mi by Lw something 355 eta prop by C L by D 1 by W. So, these are the some of the commonly used by the airliner, that how much nautical miles per fuel this can go. So, one can define this range factor, and which is say that range factor is 1 by G U by TSFC into L by D, or 1 by G U by TSFC CL by CD. So, the minimum fuel consumption for a distance, it occurs at the condition where range factor is maximum. Okay. So, that is what it is. Now, we can look at the other factor like endurance and endurance factor. Okay. So, endurance is something, the way it is defined, if the time spent in the air is of interest and not the distance travel, then one is concerned with the endurance. See, the range, when we talk about how much fuel is consumed to go certain distance. Now, here we are talking about the time which is spent in air, rather the distance time spent in air. So, endurance is the longest time an aircraft, this is the longest time an aircraft can spend in flight without landing. So, the maximum endurance of an aircraft, or the time elapsed, which refers to the condition that requires the maximum fuel power. So, the maximum fuel consumption for a time flight occurs when the endurance factor is also maximum. So, we can see that. So, the instantaneous endurance is defined as the instantaneous endurance is defined as the amount of time the aircraft will remain aloft from the next increment of fuel burn. So, we can express that d E, let us say E is endurance, is minus 1 by C T. C already we have defined, that is a specific fuel consumption. Then what we can get, E is m1 to m2 dm by minus C T, which is minus m1 to L by d dm. So, E is 1 by C L by d ln m1 by m2. Now, for propeller or turboprop engine, this E is eta by Cu L by d L1 m1 by n2, and we can define the EF, which is endurance factor, as 1 by G 1 by TSFC into L by D, which is nothing but 1 by G TSFC CL by CD. Okay. So, that is what the endurance and endurance factors is. Then we can also talk about mission segment weight fraction, that is another. So, for like let us say there is a mission flight segment, mission profile like 1, 3, it goes like this, go to that and go like that. So, this is 1, 2, 3, 4, 5, 6, 7, let us say here comes like this, it goes like this, this is 8, 9. That is it is an schematic of a typical bomber mission profile, mission segments, let us say. Okay. So, mission segment weight fraction, which is the various mission segments or legs are numbered, which this 1 is the start of the mission, and this means 1 is essentially the engine warm up or and take off. The remaining legs are sequentially numbered since then, and for let us say if a typical passenger aircraft, it would have been 1 would be again warm up and take off, 2 would be climb, 3 would be cruise, 4 would be loiter, and 5 would be land. So, like this. And now the weight fraction or the loiter weight fractions can be found from the endurance factor. So, which one can express at W2 by W1 is e to the power Txfc G by L by D, where E is the endurance. Now, it is noteworthy to mention that the empty weight fraction is given by the relation. So, empty weight fraction which is given by W E by W O A W naught C K V S. So, this A, C, these are constants which are provided by the manufacturer of the aircraft, and K V S is the variable sweep constant. Okay. Now, another thing is that what happens when you have head and tail wind. So, when aircraft is in flight, it is moving relative to the body of air through which it is flying. So, the maintaining the accurate ground track is not easy unless there is no wind at all, which is a very rare occurrence. So, the pilot has to adjust to compensate for the wind, and in order to follow the ground track, let us say if this is the aircraft, then if this is the headwind and this is how the aircraft is moving, then V g minus, so this would be V infinity minus V headwind. So, the pilot will calculate the headings to fly for each leg of the trip prior to the departure, and using the forecast wind conditions or direction and speed supplied by the any meteorological authorities for that purpose. So, these are typically acquired and updated several times per day, but obviously, if there is unpredicted weather, that is a different situation. So, this is the tailwind. So, the general aviation pilot will often make use of either this flight computer and a typical slide rule or purpose design to navigate to calculate the initial headings. So, if there is a headwind, then he has to adjust this. If there is a tailwind, then the adjustment is made accordingly. Okay. So, as we can see, if the flight time will depend on both the desired cruising speed of the aircraft and the wind. So, if there is a tailwind, then you can see the flight time will be shortened, because this will actually provide the favorable thrust, whereas if you have a headwind, then it will increase the flight time. So, that is how it is going to affect. Now, also another factor which one has to count for that is the route planning. Okay. So, the pilot planning a flight under VFR, which is visual flight rules, which usually use an aeronautical chart of area published for use of pilots. So, the map will depict controlled airspace, radio navigation aids and the airfields prominently, as well as any hazard to the flying such as mountains, etc. So, it also includes sufficient ground details like town, roads, wooded areas to aid visual navigation. So, the pilot usually chooses a route taking care to avoid control airspace that is not permitted for the flight, like restricted areas, danger areas and so on, and the chosen route is plotted on the map and the lines drawn are called the track. During flight planning, 2 points to be taken into consideration. One is point of no return, second is the critical point. These points will talk in a moment. Now, the point of no return, so PNR is known as the also known as PSR, point of safe return. This is the farthest point along the track that the pilot can fly towards the destination and have sufficient fuel to divert to an alternate with safe reserves on arrival. In other words, one can say that it is the pilot's last chance to assess his or her prospect of a successful approach and landing at his destination and decide whether to go on or to divert. If any doubt exists, he or she must divert to the alternate. So, there are number of methods which can be used to calculate PNR or PSR, and one of the most favored uses what is called specific fuel flows, SSF. So, this is mostly used is SSF. These are calculated by driving the planned cruise fuel flow by expected ground speeds towards the destination and towards the alternate field. Normally, two cases one can consider. One is when the alternate is the departure field, and second option is the alternate is on track between the departure point and destination. So, this is how point of no return or PSR is accounted for, and the other one is the critical point. So, similarly equal time point referred to as ETP, also critical point, is the point in the flight where it would take the same time to continue flying straight or track back to the departure aerodrome. So, ETP is not dependent on fuel, but wind giving chance is ground speed out from and back to the departure aerodrome. In nil wind condition, the ETP is located halfway between the two aerodromes, but in reality it actually shifted depending on the wind speed and the direction. While distance to a PNR is dependent on fuel availability and fuel flow, the critical point, the CP, is independent of fuel consideration and is based on mostly depends on ground speeds only. Okay. And the other one which is called the specific impulse. So, specific impulse is defined as that ISP, which is thrust per fuel flow rate with these things. So, the quantity enters directly into the calculation of the fractional weight change of the aircraft during flight. So, we can also write back the range with U ISP L by D ln m1 by m2. So, this is also equally applied for both rockets and aircraft. So, specific impulse, the unit will be in time. So, these are the things, and now we have looked at different factors and all these things. Now, we have slightly more discussion is left over for this endurance and all this, that we will do in the next class.